is. Alright, well, anyways.
Hello, Savannah. Happy the elf says hello.
Wow. Okay, we are doing today, or going to try to do, a little bit more on limits, but specifically infinite limits is our goal.
When is the quiz?
Yes, there is a quiz Monday. Quiz Monday. Alright, infinite limits. Before we get into the infinite limits, just a real quick rehash of sided limits. So if we have a function that's defined something like this, maybe. And maybe like this. Alright, if I want to take the limit of limit as x approaches, say, 1 from the negative side of f of x, okay, this would be coming from the negative side, so I'm going to be using this, this part right here, because I'm coming from the negative side, so like -1, 0, all the way up to 1, so I'll use this to figure out what my limit is. And if I take the limit as x approaches 1 from the positive side of the same function, I'm going to be using this one because I'm coming from the positive side, so I'm coming from like 3, 2, and then 1, so I'll use this function. So in this case, when I evaluate my limit and I replace 1 in, I'll do 2x minus 3, and I will replace with a 1 into this function because from the negative side. So 2 minus 3, so -1. Over here, I would use the x squared because, again, coming from the positive side, so that would be 1 squared, which is +1 in this case. I would ask you if this made sense to you, but I won't get an answer over the internet because you're getting this late. Brian, do you get it?
Yes.
Yay, he gets it. I'm 1 for 1, 100% today. Alright, let's do infinite limits. So now, if I want to take the limit of a function as x approaches infinity, or even negative infinity, there are basically 2 principles, well, maybe 3 principles that I'm going to have to look out for. So the first principle is this: if I have any situation where I have something over x, and I take the limit as x approaches infinity, well, x is getting infinitely big. So just kind of like if I take 1 over 100,000. If we put that in our calculator, we would get 0.0000. I'm probably going to miscount, but that's okay. You'll get the idea. This is getting close to, but not crossing, 0. So any situation that we have something like this, we're going to say that limit equals 0. Okay? Now, when does this come up? Well, when we have a situation where we take the limit as x approaches infinity of, say, 2x squared plus 5x all over x cubed. There are a few different ways that we can approach this, but basically the fastest way is to look at the highest powers of x. And if the highest power of x is in the denominator, then we basically have this situation right here. So this limit is also going to be 0 as x approaches infinity. Our other situation is when we have the power of x's are the same. So a situation like this. It doesn't really matter that I have this extra 2x. The function is mainly being dictated by the highest power of x, so I really just need to look at this piece. And as x gets infinitely big, I'm going to see that my limit is actually equal to the coefficients here, so 2/5. is my answer to that limit. Let's see here. Any others that I need to do? Yes. The third case. As x gets infinitely big, I could have the reverse of this, x over 1, or just the highest powers in the numerator. So that's going to be an infinite case. All right, so there's our cases right there. So basically, I have now gone over the information that's on page 781. So your assignment is going to be page 781, numbers 2 to 32 even. But we'll go ahead and do some examples from that page anyway. We'll do the odds. So number 1 says to take the limit as x approaches negative 1 of x times x minus 1 squared. No weird stuff here, no infinite limit, so I don't need to worry about that. So I do need to remember that I'm taking the limit as x gets very close to negative 1. And in this case, I can go ahead and replace x with negative 1 to get that. So I get negative 1, this is negative 2 squared. And negative 2 squared is 4, so negative 4. Number 3. Limit as x approaches 2 of x cubed minus 2x plus 3. So I go ahead and I put in the 2 there. So that's going to be 2 cubed minus 2 times 2 plus 3. And follow the order of operations, so I get 8 minus 4 plus 3. That's going to be a negative 1, so 7. And that pretty much covers that section of the homework. Let's try number 11 now. Number 11 asks us to evaluate the limit. It also says in this section to explain why a limit doesn't exist. So sometimes you might get a case where the limit doesn't exist in this section. So as the limit approaches 3, it's number 11, so I'm reading the wrong one. Limit as x approaches 3, negative, of x squared plus 7x plus 12, all over x squared minus 9. We do have a problem here. If we put in this negative 3, I get a 9, and then 9 minus 9, 0. So remember what we did when we talked about removable discontinuities. We can try to factor and see if we can get something to cancel. We're hoping that we can get an x minus 3 or an x plus 3 to cancel. It just so happens that when I factor the numerator, this is what I get, and when I factor the denominator, this is what I get, and we can go ahead and cancel this out, which is going to allow us to go ahead and take the limit. So the limit's going to equal negative 3 plus 4 over negative 3 minus 3, which is 1 over negative 6. So we'll write that as negative 1/6. Number 15, so that was number 11. Number 15 is x squared, my limit as x approaches negative 2 of x squared minus 4 over x plus 2. This is a definite limit, meaning that we can put in a number. We aren't doing the infinite thing. So we go ahead and put in our negative 2, but again we see that we have this discontinuity. We're going to have a 0 down there, so we don't want that. So we factor to see if we can remove the discontinuity. We see that we can indeed cancel. So our limit, we can go ahead and replace the negative 2, so negative 2 minus 2, which is negative 4 for number 15. All right, an example of one where the limit is not possible, we aren't going to be able to do it, would be like number 17. So the limit as x approaches 0 of the square root of x minus 3. And we'll say there is no limit. And the reason there's no limit is because the root is undefined for values less than 3. Because I can't take the square root of a negative without going imaginary. Other ones. Let's do number 19. Says limit x approaches 0 sine x all over 2x squared minus x. If we put in 0, we get a 0 in the denominator, but we also see that we aren't going to be able to factor and cancel with that sign. My pen is going crazy on me. Now the book does give you a hint, and you can use this hint if you want. It tells us that the limit as x approaches 0 of sine x over x equals 1. So if I want to use this, we're going to try this two ways. So the first way, we'll use this hint. So I'll factor that denominator. So I can think of this in pieces. The limit of sine x over x as x approaches 0 is 1. Okay, so I'm going to equals a 1. And then if I think of this other piece then being separate of 1 over 2x minus 1, if I think of that, I'm going to have times. I evaluate this and I put a 0 in here, so 2 times 0 is 0, minus 1 is negative 1. So this piece right here, that limit is going to be negative 1. So 1 times negative 1. Negative 1 is our limit. The other method we could use is to estimate it. And to estimate that, we're going to basically do all the same stuff. I don't even need to factor there, so I won't. And I'll just choose x to be about 0.001 or some other small value to see if I could estimate it. So then I'll do the sine of 0.001 all over 2 times 0.001 squared minus 0.001. Because remember, the whole idea of the limit is to get close to what we're actually taking the limit of without ever actually getting there. So this is a valid method to go ahead and estimate that limit. So when we use our calculator to evaluate that, we get something really close to negative 1, and we see that it gets closer and closer to that. So either way is fine there. And this second method is actually what you have to do for some other limits in the section, like number 23, where we have limit as x approaches 0 of e to the x minus root x all over log base 4 of x plus 2. Now we haven't seen logs for a while, but we can go ahead and use the change of base formula on that, because that's a base 4 and our calculator can't do that. So that's going to be equal to the log of x plus 2 all over log of 4, and then e to the x minus x. Don't go all crazy just because you see logs or exponents or anything like that. The process is still the same. So using your calculator, if we replace x with 0, e to the 0 is going to be 1, because anything to the 0 power is 1, minus the square root of 0 is still 1, all over. What is the log? 0 plus 2, so what's the log of 2? .301. And over the log of 4, what's the log of 4?
0.602.
And we can go ahead and do this division. So on our calculator we could put in, well, p-flip change it, so it's going to be 0.602 divided by 0.301. What do you get? P-flip change. It's a reciprocal. Or if you don't understand that, 1 divided by quantity, 0.301 divided by 0.602. And all we did here is we replaced the x with 0. That's all we've done.
2.
So that limits 2. Yeah, I think that's good. Do they give us any infinite limits? Yes, they do. All right, so even though the homework is up to 32, we are responsible for something like number 49 and number number 49. That's an infinite limit. So find the limit as x approaches infinity of 1 plus 2 to the x. Hello. So if we replace x with infinite, this gets infinitely big. So that limit is infinity. But it asks me to also take this limit. Suppose x gets infinitely small, so it gets infinitely negative. The same thing. So now we need to think, well, what's happening here? Well, if I have 2 to the negative 1, that equals a half. If I have 2 to the negative 3, that equals 1/8. So as x gets infinitely negative, infinitely large on the negative side, this gets really, really small. So now the limit is 1. Your class is boring, so you come to learn about some limits, infinite limits.
Basically. Actually, I'm waiting for this one to get out of that question.
Oh, I see.
So you're just
I'm just for
waiting for
the weighting project, huh?
it. Alright.
All right. The limit as x approaches infinity of x plus sine x. Okay. Well, sine x oscillates. So as x gets infinitely big on sine x, it's just going to go up and down, up and down, up and down, up and down. So, and it varies between -1 and 0, or -1 and 1. So that's not going to matter. This is just going to this is going to determine the whole limit, and that's just going to get infinitely big. Now, if you're not sure what a limit's going to do, you can go ahead and use your calculator, choose like 100,000, put it in, see what you get. It pops out. This limit is going to be infinite. It just goes really big.
49, by the way.
Now, when we do x approaches negative infinity, actually, then that's going to equal negative infinity, because that's going to get infinitely small, and that's just going to oscillate between -1 and 1. I think we're good. End lesson.